We're going to discuss this question from the LeetCoding challenge, problem name implementing trie or the prefix tree. So this is a very interesting data structure and I will make you understand it in the very naive and very simple way that if you understand this or see this video complete, you will understand how trie data structure works. So let's dive into the question first and then how can we implement this in the LeetCode. Okay, so you have to implement a trie such that you have to implement actually three methods: insert, search, and start with method. So what the actually data structure do is, if you insert some string such that apple, it insert this in the data structure, and if you like search this, it will return true. If you search app, because app is not there, it will return false. But if you do a trie search with start with app, because there is a word which starts with app, it will return true. So as you can see, you have seen this type of functionality in Google search. If you just write some word, it will auto-complete it or give you more results regarding your search. So if you just write app, it will return apple because it is there in our trie list, trie tree. And if you also interest app, insert, and then you search app, then it return true because now app is in our tree. Okay. So what you need to do is you have to build a trie. So let me do this with this example. What we will do is, first let's say we have to insert apple in our tree. So we will first make a root node, and what every trie node consists of, it consists of two things: is word and a total vector of size 26, which consisting of trie nodes, pointers to trie nodes. Initially they can be null, like initially they are initialized with null, but if there are more uh, paths down the way, we will like update them. So what actually we want to do is, we will start from the root node and then we want to insert apple in our tree. So what we will do, we will first initialize R, and then from R we have an array of size 26 which consisting of all the 26 letters. And because everything is initialized with 0, now there is an apple with A. So because this is for A, we'll make it correct that because we have found one character, and we make another node of array of size 26 which will store the next letter, which is also A, B, C and so on. But because now we have our next letter to be P, we'll use our next pointer from P and make another array of size 26. Now from P, next P will again make a pointer to L and so on. That is how we insert something in a tree. Now if we want to find out whether app is there, and when we are at the last of storing L, like there's an L, so this actually stores a node which consisting of isword and a array. So actually what does this mean? It means that for P, like this P, this is not the end, there is also more words ahead of P, and it would be L or it would be any character, but everything is initialized with 0, null. Then we'll go to the L character, and for the L character, is it the last? No. But then we go to the E, and is E the last? Yes. So everything is null for E for that node, but it is marked with true. Is word is marked with true. It means there is a word ending at E on this node. So it is actually a tree in which every node has two entities, is word and an array. If there is a word and at that node is word is true, If not, is word is false, but there is another vector which stores different pointers to different words which are which have this word. Okay, so if you want to search app in this tree, so we'll start from the root. We'll see whether a is null or not. Because a is not null, it has no character, we'll move down a. Then we'll find whether p is null, no, so we move down p. Whether again p is there, yes. It is null, no. So it means, yeah, there is a word in the list which we have done which has a character app, but ap does not need to be a word. This node is not, is word is false because app is not a word. But what we have seen is, though it is not a word, but there is a node there which represent that there is a path from a p till p. It means there is a word which consisting of a prefix of app. So we just have to insert that. So we need a different data structure or different node to store these two entities. So I'll dive you directly to the code and it will be more clear. So what we will do actually here is, we will make a struct. I hope you know that for making new type of data structure to store every node, we'll make a new struct node. So what we will do is struct try node and then put here. Then it has two entities, bool, which consisting of is word and a vector. Which consisting of try node pointers. Name it children. Now when we initialize a try node, what we will do actually, we will first make this is word false and initialize the children to null. Children is equal to, we'll make a vector of try node. We actually initializing it and initializing it with 26 cells and make them all null. That's how we initialize it. Now we will make a global root to store the root value. And now for the initialization, we'll initialize root to new try node. So what actually we have initialized is, we have make a node, root node, which consists of 26 cell vector which has a pointer and everything is null initialized. Now if you want to just insert a, because all the 26 characters represent 26 cells represent each character a, b, c, and we just mark their indices 1, 0, 1, 2 and so on. And then because there's a, what we will do is, we will make another try node and from a we will point that. But because the a is only length 1, we will make this is word. What we will do for this word, what we will do, we will initialize another node and we will make the is word for this true, because there is a word ending there. So what we will do actually now, how to insert any character. So first store n, which is the word length, and then what we will do, we make a try node, like a temporary node which will help us to iterate over the tree. Now int I is equal to 0, I is less than n, I plus plus, int k is equal to word of I minus a. So we are actually finding out the index of the word character on which we are, and then we will see if the child of that current character is null. If it's null, we have to make a new child, a new node. So current of child of k is equal to new trie node. And if there is not null, it means like there is actually a path there which exists. So it means like if we have inserted apple there and now we're inserting app, the first a already has apple inserted, so there already be a node there through a. So we don't have to insert another node. We just have to uh, move our current. So then our current will be current children of k. And after, when we have come out of this loop, we will mark this current is word to be true, because like this is a word ending at this place. So this is how we insert a word. Now what we'll have to do is we'll have to search. Searching is done in the same fashion as inserting and start with also. So what we will do is n is equal to word dot size trie node current is equal to root, and for int I is equal to 0, I less than n, k is equal to word I minus n, finding the index. And then what we will do is we will update our current while moving through the word and checking whether there is a path exists in the tree for this word or not. If at any point our current become null, it means there we cannot move further through our current. It means we have not reached our end. And if we have reached our end, though it is not sure that it would be a word or not, so then we will return current is word. And that's how we search it. And for the last, same, how to find out, start with n is equal to, so now we have to find out the prefix. Trie node star current is equal to root, I is equal to 0, I less than n. We are searching for the prefix. So k is equal to prefix of I. So now we'll move to the current, same as above for searching. As you can see, the code is like 90% same. It will be just different in the last line. So if the current path is null, we cannot move further and we return false. But if we come out of this loop, which means like there is a path from the root till this node, and we have not reached the end of any word, but there is a path, which means like there is a prefix somewhere. So we have to return. That's it. Let's submit this and check. Uh, should be its size. As you can see, it's fine. Let's submit this. So as you can see, it's accepted. I hope you understand the implementation. If you still have any doubts, feel free to post it in the comment box. Thank you for watching this video. Keep coding. I'll see you in the next one. Bye.